Hello and welcome everybody. Today is the day 18 of our Smart 25 Days Challenge, and today we are going to make a very easy to implement but yet very useful smart contract that would be a credential issuing smart contract. So, by the help of this smart contract, any organization can issue some credentials and they can also verify whether the credential is valid or not, and this can be checked by anyone. So let's start making it. Okay. First of all, let us make our file called as okay. And let's start making our smart contract. Contract credential issuance. So, for first of all, what is the main thing in this smart contract? So the main and the most important thing is the credential itself. Okay, so that credential for that credential for storing the details about that, you are creating a struct here. Okay, and let's call this struct as credential. And this credential struct will have the following properties, which are the address of the issuer, then the string of let's the data type the string and student name, then another string that would be the course name, then one more string that is the completion date. Okay, okay, looks cool. So this is the struct basically, and now let's create a mapping to associate bytes 32 with the credential struct. And you may be thinking, what is this bytes 32? So this bytes 32 is basically the credential ID that would be unique for each credential. Okay. And I would be showing you how we are going to generate that. And let's keep this mapping as private and call it credentials. Okay. And let us declare one event too, that is the credential issue, and the arguments for the parameters for that would bytes 32 indexed by the credential ID. If you guys are having any problem in following this, or if you are not able to understand what's going on, then I would recommend you to please go through my previous videos. Okay, in the previous days, we have covered everything, each and everything in detail, and that would be very helpful for you. So please go through it. Otherwise, if you are able to understand, then keep following. So, and as to after the student name, just the completion date. Okay, looks cool. And that's it for the event. We have declared the event. Okay, that's it for the definition of the event. Now let us make the functions. So in this smart contract, we are going to make just two functions. That is, first would be to issue the credential, and the second one would be to verify whether the credential is valid or not. So let's call this function as issue credential only, credential, and the arguments taken by it would be address of the student, then student memory, student name, and student memory, course name, and then completion, and then a string memory completion date. Okay, string memory completion date. Um, it- and looks good for this, and let's make this public. Okay, so now let's implement this function. So first of all, we would be implementing some required conditions, and for this I am keeping only one required condition, that is that the student's address should not be zero address. Otherwise, we will say invalid student address. And for you, you can implement the required conditions for these also. Okay, the other parameters, but for now I am just implementing one. And so this is a very small task for you. You can add the required conditions for others too. And otherwise, we'll say the student address should not be a zero address. Okay. Otherwise, we'll say that it's invalid. Yes, invalid student address. And then, so here comes the part of generating the credential ID, and that is the data type would be, it would be of bytes 32 uh, and credential ID. And how we are going to generate it is in the following manner. We would be using a keycat 256 and then ABI dot encode tag. So we have used this before also. And in this, what we are going to pass, we are going to pass student, then student name, then course name, and then completion date. Completion date. So looks cool, and just so, and the required condition again. So what we have done here is we are using a keycat 256, okay, hashing function. So this is, as this is of 256 bits, that is 32 bytes. So we have stored that in a bytes 32 data type. And then what we are going to do is we will make sure that same credential does not get issued twice. So for that, what we will be doing is in the credentials mapping, in the credentials mapping, check for the specific credential ID, and after retrieving, okay, in this mapping, we are accessing the credentials mapping by using the bytes 32, that is the credential ID, as the key, and we have accessed the so by that we have accessed the credential struct associated with a particular credential ID, and in that particular struct we would be going to check for the issuer property. Okay, and for that, so the issuer should be okay, issuer, yes, the issuer property double equals to address zero. Okay, yes, credential dot issuer. Okay, should be a zero address. Otherwise, we'll say that if it's not zero, then we can say that the credential already issued. Okay, and so yes, credential ID. Okay, so good. So then credential, and so now we are making a new credential struct in the memory, new, and then we would be, what we would be doing, we would be associating the credential ID, particular credential ID, with that newly created credential struct. Okay, new, let's name this new credential only, new credential, and so this is the constructor for the credential struct, credential method. The okay, in this struct The issuer would be the person calling this function, issue credential. So it is the message dot sender. And the student name is basically the student name passed by him. Student name, course name, and then just one more thing, that is our completion date. Okay, and completion date. So it's good. So now access the credentials mapping, and then what to do, just associate the particular credential ID which you have generated just here. Okay, credential ID with what? Credential ID with the key is the credential ID, and the newly created new credential struct is the value. Okay, and new credential, good to go. Just now emit the function, emit the event, not function, emit the event that the credential has been issued. So just emit credential issued, and the credential ID is okay, credential ID only. The issuer is message.sender. Message.sender looks cool. And the student name is student name passed by him, and the completion date is also the completion date passed by him. Okay, so looks cool till here, and now we are good to go to move on to our second function. And this function to issue a certificate is now complete. So let's move on to our second function, that is basically to verify whether the credential is valid or not. Credential, and it would be taking a the bytes 32 credential ID. Credential ID need to be a public function. View returns address issuer string memory. Okay, memory. Okay, yes, memories. Then name, and then string memory course name. Course name. Then string memory. Yes, completion. Completion date. Okay. So now just retrieve the credential. Okay. Struct. Okay. So the data type would be credential. Credential, and it should be in the storage because we are retrieving the already existing credential struct, and we are going to access this credentials mapping by using the bytes 32. There's the credential ID, it will get the specific credential struct, and let us store that into a variable called as credential. Okay, and to retrieve the value, just access the credentials struct, not credentials struct, credentials mapping, and credentials mapping into that, the pass the credential ID, okay, as a key, and get the value, and then store that specific value, that credential struct you retrieve into the variable called as this small c credential, and then we would be checking that it should be a valid, okay, it should be a valid credential. So we would be accessing the credential dot issuer. Issuer should not be equal to zero address 0. Okay, otherwise we'll say invalid credential. Okay, and just return the values. If everything works fine, then just return the credential dot issuer, the credential dot student name, credential dot course name, and the credential dot completion date. Okay, and just that's it for the return part. So we are good to go. Looks like our smart contract is now complete. And so this was a very easy but yet very useful smart contract. So let's compile and deploy it and see how it's working. Okay. So we have now deployed it. So see, you can, as you can see, so any organization can issue the certificates using this. And for the image part, we'll try to cover it in the full series where we would be making the full depths. Okay. After these 25 days, after the Smart 25 day series, I'm planning to work on some full stack projects. Okay. And that I would be covering, will try to cover if you want the image part 2 and all. So for now, this is a simple yet useful implementation in which, okay, this person is the organization which wants to issue some certificates, and this is the student one. Okay, so we have copied his address and the address of the student name, let us say student one only, course name, let's say algorithms, and the completion date, let's say some, okay, 16 only, 16/7/2023. Let's see. Okay, so as you can see in this, so this gets successfully executed, and in the event logs you can check. Okay, so the credential ID is there, this credential ID, and external entities can check for it, can hear it, and can listen for that. And you can see the credential ID is this. And if anyone wants to check, okay, whether the particular certificate is valid or not, is a legal certificate, so he or she can just enter this credential ID and verify. Okay, so everything, the details, that is, the issuer is this guy only, and the student name is student one, the course name is algorithms, and the completion date is this. As I always say, you can definitely add some more functionalities to it if you want, and you can test it out, play with it. So that's all from my side, guys. So we'll meet on the day 19. Till then, bye bye, and thanks for watching.